And I'm going to share my screen with you. Okay, so let's have arrow here. Now let me start continue yesterday's PowerPoint. I think we talked about the concept of normal or Boyce-Codd normal forms, but we actually did not get into the details. So let me see which part is that. I did that. Second normal form, we did that. Okay. Third normal form, we finished that. Okay, Boyce-Codd normal form. So here is a definition. Let me start to show the slide. So this normal form is a very interesting one to me because it does not require any prior normal forms to begin with, like a first normal form or second normal form or third normal form to begin with. However, this normal form is actually more stringent, stronger than any of all these three normal forms. Okay, so what does that mean? If a normal form is violating the first, second, or third, then you will definitely violating the Boyce-Codd normal form. Okay, I'll give you an example to show that. And on the other hand, if a table is in the first or second or third normal form, it may not be in Boyce-Codd normal form. So therefore, this normal form, you can just think of this way. So if you say I have table, the table according to third normal form, there's no extra redundancy. However, if you use Boyce-Codd normal form, they will tell you that you do have extra redundancy. So therefore, this normal form is much stronger than that's number 3, third normal form. However, it's not the fourth normal form because we have formally, if you look at chapter 11, that we have a formal concept of fourth normal form and fifth normal form. But this one is not fifth, fourth, or fifth. So people tend to classify this Boyce-Codd normal form as 3.5 normal form. It's somewhere stronger than third normal form, but not as strong as fourth or fifth normal form. Okay? Okay, so what is definition? The definition is basically saying that if you find in a table there's a functional dependency, the determinant of the functional dependency is not a key. In this case, we're talking about the candidate key, any key, the key which are the columns which can determine every other columns. Okay, so that's the candidate key concept. If the candidate is not a key, then you can say that this table is not in Boyce-Codd normal form. So by using this normal form, you do not need to say what is the primary key and what are the other functional dependencies are out there. You just need to find one which is, which has, whose determinant is not a key. Then you can make a judgment right away that the table is not in Boyce-Codd normal form. Okay, so repeat. There's no need for any other normal forms to begin with. And there's no need to identify the primary key. Okay. Now, how do you check Boyce-Codd normal form? First of all, you do need to draw FDD. So if you have a functional dependency diagram, so if you do say some functional dependencies, then draw them on the table. Okay. And then check if the determinant for all of this functional dependency is a candidate key or not. Okay. So you may have like 3 or 4 functional dependencies. You can identify it on the table, but if any one of them has a determinant which is not a key, then the table is not in Boyce-Codd normal form. Just need one, okay? So this is an example I think we were talking about last class. See here, a table with a branch name, customer name, loan number, and amount. All right, so there may be relationship between loan and the customer or branch. So the relationship, typically, you can assume that one loan can have multiple customers. A customer may have multiple loans. A branch may have multiple loans. A loan may be issued, the loan number actually may be issued by same loan number may be issued by different branches. Okay, so all the relationships are possible. However, there's one functional dependency that is for sure. That is, if you know loan number, then you know the loan amount. All right, so you have functional dependency like that. Okay, so now you ask, is the loan number the determinant, the key for that table? As I said, no, because loan number does not uniquely determine a customer, because one loan may have several different customers, like joint loans, husband and wife, partners, they have all share the same loan, right? So by just know the loan number, you will not be able to tell who is the customer. Okay, so you say that all these concepts of normal forms require understanding of functional dependency. Okay, all right. So now this table is not in Boyce-Codd normal form. So the question is how we are going to fix it. Okay, to fix it, the procedure is same as the third normal form violations. So to fix Boyce-Codd normal form, the procedure is the same as the one you are going to fix third normal form violations. Okay, so if functional dependency like a loan number determines amount, right? So loan number is the determinant, and loan number is not a candidate key for the table. Okay, the branch may have that. So that table is not in Boyce-Codd normal form. So this is the judgment. And now let's say how we going to fix it. All right. So first of all, by using this relationship between loan number and amount, you are going to make a new table. Okay, with the determinant as a key. So loan number is the primary key for the table, and amount is non-key column. So you make a new table like that. And then you remove these two columns from the original table and use everything else. Remember, everything else was basically just branch name and the customer name only, right? Only these two columns left. So everything else plus the transistor. So you need to get that determinant as a transistor back to this table again. So then you're going to create a second table like this. Does it ring the bell? So that's how you're going to fix third normal form violations, right? Okay, so basically just use the transistor, and then whatever determines on the transistor, make a new table. And then everything else plus the transistor, make a new table. Okay, so regarding this new table, what should be primary key? What should be primary key in this case? Can anybody make a judgment on that? So you have a table with a branch name, customer name, and the loan number. What should be primary key for that table? Yeah, all three. Very likely it's going to be all three. So if you say all three, is probably like just you're assuming that each bank branch can issue loans independently. So for example, Akron branch can issue 101 loan number, and Fallon also can issue 101 as a loan number. Okay, and then of course one loan can have several customers. And then one loan number can also have several branches, and one customer may have several loans, and one branch can have many loans also. So basically, in that case, you're going to use all three as a primary key. Okay? If there is a possibility that all branches are issuing loan number not independently, but using the same loan number across the entire corporation. So for example, the whole bank system issues just say 101, okay? That's one issued, then it's not going to use that 101 again for another branch. So if that is the case, then if you know the loan number, then you can identify which branch it belongs. All right, so if that is the case, then this table will have to do another so then this table will also violate the Boyce-Codd normal form. Let's just work on that example. Okay, so if in case, let me use a whiteboard to do that. So let's start with new one. So case one. Oh. What is it? Do you want to keep your ink annotations? I think I have something wrong here. Let me see. Okay. So I was trying to write on the whiteboard. Okay, it's working now. All right, so here, let me erase that first. So we have we just talked about two cases. So in case 1, assuming each branch issues loans in the N and delay. What does that mean is the same loan number may be used by different branches. In that case, the loan number just determine the amount and will not determine the branch. So then this loan number does not determine the branch. Okay, so in that case, if that's the case, then we will make 2 tables, and we will still have violations. So the table is not a Boyce-Codd normal form. The table is not in B, C, and F, okay? Because loan number is not a key, okay? And then to fix that, you are going to create 2 tables. To fix, you're going to create 2 tables. One table with the transistor loan number as a determinant, as a key, and amount as a non-key column. And then everything else, everything else include the branch and the customer. Was customer ID or just customer? I forgot that. I think, let me just put that back. Maybe somewhere here.
I think it was customer name.
Was customer name, really? Let me see. Customer loan number, customer name. Oh, customer name, that's even more difficult. So customer name. Thank you for that. And then customer name. So those are everything else. Plus, you need to put a loan number back. Loan number back as a transistor. So that's going to be like a foreign key in here, right? So this is a case 1 case. So if you have that, in this case, then you're going to use branch, customer name, and all loan number as the primary key for this second table. Now let's look at the case 2. Case 2. So assume each branch issues loans for the corporate. Okay, and loan numbers is issued as you issued by the corporate. So the loan number will not repeating. The loan number will not repeating. You are not going to have the same loan number for different loans. The loan number, it will not be reused. Okay, so in that case, then if you know the loan number, then you know which branch issue it. So then you're going to have a loan number. Loan number determines branch and also determine the amount. Right. So now the table will be still in not Boyce-Codd normal form. The table is not in Boyce-Codd normal form for the same reason, because loan number is still not a key. It's not a key. Okay, so for the same reason, because one loan may belong to several different customers. So if you know the loan number, you cannot tell who is customer. Okay, so therefore, this is not Boyce-Codd normal form. So to fix that in this case, then you're going to use that new functional dependency, which has loan numbers determinant and amount and the branch both as non-key columns. Okay, and then in that case, everything else will be just customer name only. Everything else, the customer name, and plus the transistor loan number back. Okay, and then this will be foreign key, and the both together will be primary key for this table. So you need both customer name and the loan number to be. And this actually we have a strong assumption, assuming that the bank does not have a lot of customers who borrow loans, and then no customers have exactly the same name. Customer names can be unique, but that may not be always the case. Okay, so better example might be just using customer ID in this case instead of customer name as a identifier for the customer. So anyway, we're assuming that the small bank and branch has only limited number of customers, and no two customers will have the same name. So if that's the case, then we'll have this and that two as a primary key. So depending on the two different cases, we may end up with different two different splitting. Okay, so anyway, that is how we do Boyce-Codd normal form fixing. Now, this procedure is the same as a third normal form procedure, and it also have the same drawback as Boyce-Codd as a third normal form violation fixing. So that is the procedure may not be clean. So you may still need to check this, check possible violations again. So what would be possible violations? So for example, amount, branch, I don't think they should have any functional dependencies, right? So in this case, we have only possible functional dependency, which is that loan number determines both amount and a branch, but the loan number is already key. And for this one, there's no functional dependency at all. So I guess you cannot use loan determine customer name, or you cannot use customer name to determine loan either. So therefore, there's no functional dependency between these two columns. So therefore, they both will be Boyce-Codd normal form. Okay, so in this case, we have something which is clean. All right. So this is an example to show that how we're going to identify Boyce-Codd normal form violations and how do we fix those violations. Now let me go through a couple of examples. Let me say what is the next example. I think the next example probably is like a club example. Let me start showing that. Okay, so we did that. Okay, so procedure to fix is same as the third normal form violations. Also fix Boyce-Codd normal form. What is this? BCNF, NF, that's too much. BCNF violations is not clean, okay? Now let's look at this table. This table is actually a very interesting table. Let's just give you a context. So you're all familiar with places like a Sam's Club or Costco, do you? Okay, and they have different warehouse centers, right? For example, Sam's Club has a Fairlawn Center and also have a what is that? The Cuyahoga Falls also has center. So basically, that warehouse has many different centers, and each center will have many employees, right? That is not really assumption. And then each employee works for one center, right? So that is also not assumption. It's pretty realistic assumption. Okay, so each employee works for one center. All right, and the second part, if you walk into those centers, if you had experience, you probably have that. So basically, if you have any questions about electronics, then you have an employee who will handle your questions. Who is responsible for all these electronics? Okay, if you have questions regarding some kind of food or grocery items, then they will have a special employee to handle that. So each part can be stored in many centers, but each center has many parts. Okay, that's a standard part. Okay, but I was talking about third one. Each employee manages many parts, but each part is managed by only one employee. Does it make sense? Okay, so you have one employee who manages many parts, specialize those parts, but then each part is handled by only one employee. Okay, that's assumption. And then each part can be stored in any centers, right? So basically all the centers, all warehouse centers are selling the same kind of parts, okay? And each center has many parts. All right, so based on that assumption, based on those assumptions, now I have this table that's basically center, part number, employee number, and then in stock, which basically that's just the quantity on hand, how much of the stock, how much of the part is in the center, okay? And whether the part is discontinued or maybe some kind of status, whether it's discontinued or not, okay, that's status. So who can tell me what should be primary key for this table? Even though primary key is not really needed for Boyce-Codd normal form, but I'm just trying to use this example to show you, to demonstrate to you that even though a table is in third normal form, however, the table may not be in Boyce-Codd normal form. So is this table in third normal form? So let's say, what is the primary key for the table? Can anybody point out? If I use center and the part number, would I be able to determine everything else? If I know the center and also part number, will I be able to determine the employee who works for the center? Yes, I think so, right? Because if you know the part and center, for example, if you walk into Fairlawn Center and then you say you have questions about some computers, then you know which employee is responsible for that, right? You're looking for that particular employee to help. Does it make sense? So center plus part number should be able to determine the employee. And the center and the part number should be able to determine in status, in stock quantity, of course, and also status, of course. So therefore, the primary key for that table, if you try to identify this as trying to use third normal form to check that, you should have center part number as a primary key, right? Okay, so now everything else will be non-key column, like employee number, in stock, and status. So if you're trying to say whether this table is in third normal form, then you will try to say whether there's any functional dependency among non-key columns. So you're going to check to see whether there's any functional dependency between employee number, in stock, and the status. Do you see any functional dependencies among these, among the three? Employee number determines part quantity? No. Quantity determines employee number? No. Right? Employee determines status? No. Status determines employee? No. Quantity determines status? No. Status determines quantity? No. Right? So basically, you cannot see any functional dependency among these three non-key columns. So therefore, this table is in third normal form. However, this table is not in Boyce-Codd normal form. Why? Well, if I know employee number, can I tell which center he or she is working? If I know the employee, Can I tell which center that employee is working? Yes, right? Because we assume that each employee only works for one center, right? So if you know the center, if you know the employee, then you know where he works, which center he works. So therefore, we have functional dependency like this. So I'm going to use a whiteboard in this case. Okay. Let me write this down. So first, let me just write this down here also. So the PK equals to center plus part number, okay? And then the table, so there's no FDs, functional dependencies, among non-key columns. So which are non-key columns? We have three. We have center, no, not center. We have an employee number, and the in-stock quantity, and the status. Okay. So there's no functional dependence among the three non-key columns. Thus, the table is in Boyce-Codd normal form. Okay. Now we can check second normal form. And then what we do is we say that there's a functional dependency between employee number, which determines the center. However, is employee number the key for the table? No. Employee number cannot determine quantity, cannot determine part, right? Because the same part may be located in different places, in different locations. They have different quantity, different status. So therefore, this determinant, so yet the determinant EMP number is not a key, not a candidate key for the table. So therefore, the table is not in Boyce-Codd normal form. Okay. So now you see the conclusion here. The table is in third normal form. However, the table is not in Boyce-Codd normal form. Okay, so that means the Boyce-Codd normal form is more stringent than the third normal form. Now, how do we fix that? So to fix, we are going to use Boyce-Codd employee number that determines center. Use that functional dependency to make a new table. Employee number as a key, and the center as non-key column. And then everything else. So originally everything else, if you look at the original table, what was everything else? Let me try to say that. Everything else include part number. So you get rid of center and employee number, okay? And then part number, in stock, and status, only these three columns. So you're going to use part number, in stock quantity, in stock, just trying to see, okay. In stock, and then status. So this is everything else. But don't forget to put this transistor back, so employee number again. Employee number again. So now you split that original table into two tables. The one table is basically tell you which employee works for which center. And then the second table shows basically the information about the part and who is responsible for the part. So who can tell me what is the primary key for this table? What is the key for this table? So originally we have employee number, we have center and a part number as a key, but now since that key is split the two parts, so what should be primary key for this table? Anybody? So you need a part number definitely, right? But you also need the employee number, right? Make sense? So if you know the employee number and the part number, then you know what is the quantity for the part. And also you know the status, right? Because this employee, if you know the employee, you know which center that the employee works for. So if you know the center, then you should know, for that part, how much in stock and what is the status of the part. So therefore, the primary key should be both part number and the employee number. Okay. And then in this case, do we have any other functional dependencies? Can you tell any other functional dependencies? For this one, you have only one. That's employee number determines center. That's not a problem. So that is actually fine, right? So basically, that's just saying that the employee number is a key. So this table is already in Boyce-Codd normal form. How about this second table? Do you see any other functional dependencies? So the only thing I think you can tell is that the part number and the employee number both together should be able to determine in stock and status. So that's one functional dependency because we already identified the part number and the employee number is the key. So they should determine everything else. However, besides that, do you see any other functional dependencies? Do you see any? Part number determine in stock determine status determine employee number. I don't see any. So I guess this probably also clean. This result is also clean. It's already in Boyce-Codd normal form. Okay, so and this result is good. Boyce-Codd normal form satisfied. Okay, satisfied. All right. Any questions regarding this example?
I have a question.
Yeah.
So why is employee number not a foreign key when in a different example, I think that it would have been?
This is actually a foreign key. This is a foreign key.
So the primary key is part number, and then the foreign key would be employee number, correct?
No, this table is going to use employee number as a foreign key, and also the primary key for that is also going to contain both. It's going to use this.
Okay, so the primary key is both, but employee number is also a foreign key.
Yeah, employee number is a foreign key because you see there's a primary key is duplicated here as a foreign key. So that's always the case when you do third normal form violation and Boyce-Codd normal form violation. If you're trying to fix that, you're going to use transistor. The transistor is actually going to be foreign key for the second table. So what happened here is that this foreign key is going to be part of a primary key for the second table. Is that like a weak entity thing? Right? Is that how we do weak entity? Do something like that? Weak entity, you get a primary key from the strong entity duplicated inside a weak entity table, and also that foreign key will be also part of a primary key. So this is kind of like a weak entity, right? Maybe. I think this should be, if you're trying to understand what I mean here. Good question. So basically, if you're trying to do, say, employee here, a strong entity, which have employee number as a key and also a sender as non-key column. And then you're going to have, this is more like a part. Okay, and then it has a part number, and it has in stock, and also have a status. Okay, and this may be optional, required, whatever, does not matter. So if you convert this into the tables, into relational model, you're going to create one table for employees, which is going to be like this one, right? And then you're going to create a table for parts, which is going to have part number, in stock, and status. And plus, you're going to duplicate the primary key for employees, strong entity into here as foreign key, like that. And also that foreign key is also part of the primary key. So perfect. This is actually, that shows that if you're combining this kind of one-to-many with basically just like a, what is this? Like a weak entity, then you're actually getting Boyce-Codd normal form violations. Okay, now let me go back to the original table again. So originally, we have that table. Let me start from here. So we have a center, part number, and employee number, and their status, whatever, right? So we identified that center and the part number should be primary key for this table, right? And then we have a situation like this. In this example, this is a strange example. That is the employee number, which is non-key column. Employee, that's non-key column. The employee number actually determines a part of primary key. You see that? So if non-key column determines other non-key columns, then we say that is a violating third normal form. But however, in this case, we have non-key column determines part of primary key. Okay? This is also different from second normal form. Second normal form basically said part of non-key column determines other non-key columns. So it's opposite to this. So if you have part of primary key determines other non-key columns, then you're violating second normal form. But this case is not like that. This case is actually opposite to that. We have a non-key column determines a part of primary key, rather than part of primary key determines a non-key column. Make sense? So therefore, this case is kind of different from second or third normal form. So now, what if we have a table violating second normal form or third normal form? Would they be also violating Boyce-Codd normal form? We said yes, right? So now let's use example to show that. Okay. So this table, do you remember this? This table was we used that as example to show second normal form violations. You remember that's the first table in chapter 11. We used that to talk about different anomalies, right? So this table is violating second normal form because you have a primary key consisting of student ID and a course number. However, you have partial functional dependency. That is, name and the major depends on the student ID only. Course number and credit, course title and the credit depend on the course number only. So you have partial functional dependency. So with that table violating Boyce-Codd normal form, so you just look at functional dependency. Look at the functional dependency. So let me just skip that. So let's go to whiteboard again. So we have a table. Basically, we identify the functional dependency. That is student ID determines student name and major. That's one functional dependency. Another functional dependency is a course number. Determines title and the credit. Right? So you can identify other functional dependencies based on these two. Or based on any one, we can already know that this is a functional dependency, but determinant student ID is a student ID the key, the primary key for the table. Is the course number the primary key for the table? Look at here. No, they're not. Neither one, right? Student ID is not the primary key because it's only part of primary key, right? Part of primary key is not the whole primary key. Okay, course number is not the primary key either. So therefore, this table is also violating Boyce-Codd normal form. Make sense? Okay, so you wonder, if I treat this as a violation of Boyce-Codd normal form instead of second normal form, and I use the Boyce-Codd normal form procedure to fix it, will I be able to get the same result? Let's try, okay? So let's try this. So let's just say I'm going to use the first one to try it. Okay, so let's just say the table. So let's get rid of this one first, okay? This one first. Just use this one. And yet, student ID is not a key, right? Because it cannot determines. I try to simplify that. Functional determines like a, cannot determine course number, title, and the credit columns. So those columns cannot be determined. Okay. So therefore, this table is not Boyce-Codd normal form. So the table is not in Boyce-Codd normal form, right? Because determinant in the functional dependency, in this functional dependency, determinant is not a key. So now let's say to fix that, okay? So we're going to use student ID that determines student name and the major. Use that to make a function to make a new table. So for that, we are going to create a new table with student ID as a key, name, and the major as non-key column, right? And then everything else. Remember, everything else include course number, title, credit, as everything else, plus the transistor. So you need to put the transistor back. So student ID as a foreign key, right? Okay, put that back. Okay. And now so we end up with two tables. The first table, do you see any other functional dependencies besides the student ID determines name and the major? Can you say name determines student ID, or name determines the major determines student ID, and major determines student name? Probably not. So this table is already fine with Boyce-Codd normal form. However, what about the second table? Second table, you say that course number determines title and the credit, right? See that? However, the course number is not a key. Do you see that? Because the course number, one course may have many students. So there's basically the course number is going to repeat it. So course number cannot determine students. If you know the course number, you cannot determine who is taking the course. So therefore, this table is not this is not. So let me just write this down. So because of function, so this table, the second table is not in Boyce-Codd normal form because course number determines title and credit, yet course number is not a key. Yet course number is not a key. Okay? Just when you do your homework, you probably trying to follow this format, make a judgment correctly. Okay, so why you say this is not in the normal form? Okay, for the reason. Okay, you need to give the right reason, because this course number is not a key. So to fix that, I'm going to use course number, which determines title and the credit, to make a new table. So the new table will look like what? Course number, title, and the credit, 3 columns, with course number as the primary key, the determinant is the primary key. And then everything else, remember everything else in the original table, which is the second table here, we already remove the 3 columns, so everything else just student ID only. So you add a student ID, everything else, which is student ID, plus the transistor. So you need to put a transistor back. So this is the course number. So that would be like a foreign key in here, right? Coming from here. And then this student ID was originally coming from the original table. So now we end up with 3 tables. It's 1, 2, and the student table, 3. So we end up with 3 tables. So if you look at the 3 tables, this table, what is the primary key? You're going to have your student ID and the course number together, right? Both. So if you fix that as second normal form, you're going to get the same 3 tables, do you? This is junction table, and this information about the course, and other table was about students. So this table is junction table between course and the student. So therefore, the result is the same. Isn't that beautiful? Even though we do not use second normal form violations, but we treat it as a Boyce-Codd normal form, and then we will reach the same conclusion, right? That's pretty, right? Okay, so that's a science, all right? The science, a lot of times, is beautiful. All right, so now let's try to see whether we have another example to show third normal form violations. Okay, so this one is fixed. Okay, then we have third normal form violations here. Okay, so we already work on this one. So for this one, we are, this was like a publish your table. So basically, publish the title ID, and the title ID is primary key. Title ID determines title, determines editor, who is the editor, and also the form, right? So assuming that is a publisher, and then all we do not have many editors. So basically, all names are unique. All right. So this table we said was violating third normal form because we have editor name determines editor form, right? So in that case, we have non-key column determines another non-key column. So therefore, this table is not in third normal form. So what about Boyce-Codd normal form? What about Boyce-Codd normal form? Is this table violating Boyce-Codd normal form also? Yes, of course, because the functional dependency editor name determines editor form. The editor name is not a key for the table, right? The determinant is not a key. So editor. So let's do that in the whiteboard. Okay, so we have the table. Let me repeat that table again. So we have a table like title, ID. That determines title. Like SK, there's what is this? There's ISBN number, right? There's a book title, and then editor. Assuming the editor names are unique in the publisher, and then phone number. So assuming that many editors share the same form. So we have functional dependency in this case. That is editor name determines editor form. We said that. So because of this table is not in third normal form, but also this table is not in Boyce-Codd normal form. This table is not in Boyce-Codd normal form. It's not in Boyce-Codd normal form due to the functional dependency. Editor name determines form, but editor name is not a key for the table. Is not a key. So here we're talking about a candidate key. Okay, because editor name cannot determine title, because one editor may have many titles, right? He or she may edit many titles. So this is not in Boyce-Codd normal form. So now let's say if we're going to fix that third normal form, the result will be the same as the one you fix the third. If you fix this as Boyce-Codd normal form violations, the result should be the same as the third normal form violations. So let's say we have editor name to fix. Okay, to fix. So editor name determines form. So you're going to make that as a new table. Use editor name as a transistor, as a primary key, and a form as a non-key column. And then everything else from this original table. So that means title ID and a title. Title ID and the title with 2 columns will be everything else. Plus, you need to get editor name back, the transistor back, editor name. Okay, so then you're going to make that as a second table. So you end up with 2 tables, 1 and 2. And so if you compare this with your third normal form violation fixing, then the end result is also identical, same table. Okay, all right. So I think what do we show? What is the result by using this example 4 and 5, and we could there's no more. So I will just summarize that using whiteboard then. Okay, so what do we see here? Okay, if a table, so let me just write formally. So conclusion. Okay, based on the examples we just demonstrated, okay, first, if a table is not in second normal form, it will be not in Boyce-Codd normal form. Okay. Second, if a table is not in third normal form, it will not be in Boyce-Codd normal form. Okay. Number 3, if a table is in second and third normal form, it can still be not in Boyce-Codd normal form. So now let me try to ask you a question. What do you think of that? If a table is in Boyce-Codd normal form, let me just do this, actually write this question, easy one first. Okay, so like that. If a table is not in Boyce-Codd normal form, will it be in second or third normal form? What's your answer? If a table is not in Boyce-Codd normal form, will it be in second or third normal form? Anybody? Just use the first 3 conclusions to make inference on this one. What do you think? So if a table is not in second normal form, then will definitely be not in Boyce-Codd normal form. If a table is not in third normal form, then definitely will not be in Boyce-Codd normal form, right? However, if a table is in second normal form or third normal form, it can still be not in third normal form, right? So what's your answer to this question? possible, isn't it? Possible, yes. Even though a table is in the second or third, but it can still be not in Boyce-Codd. So this is possible. So is yes, right? Okay. What about this one? If a table is in Boyce-Codd, is in Boyce-Codd normal form, will it be not in second normal form or third normal form? What do you think? If a table is in Boyce-Codd normal form, it is possible that this table is not in second normal form or third normal form?
It's not possible.
Not possible. Does everybody say that? Because if a table is not in second normal form or third normal form, then will definitely be not in Boyce-Codd normal form. Okay, a little bit tricky, right? It's good. So make sure you understand just how do you answer this question. So this is no. Okay. How do you answer this kind of questions? So just make sure that Boyce-Codd normal form is stronger than second and third. Just remember that. Okay. So a table is not in second or third, but definitely not in Boyce-Codd. Okay, so we have 15 minutes left. I think my slide is finished. Within that 15 minutes, I think I can go ahead with SQL programming. We're not actually going to put our hands on to type commands, but I will just ask you to do this. If you go to eCourse, let me tell you which place to go to. So we are preparing for sample data for exercise. So let's go to, let me tell you which place to go. This is Edge, gonna use Chrome. So it's all Chrome here. Okay. Let me see which place to go to. If you go to public maybe, public. And then there's a place called under eCourse resources. There's a place called scripts, some kind of script loader. Do you see that? SQL console. Where is that tool? Oh, scripts loader right here. You see that? Okay. Does everybody see that? Okay. So just load the scripts. And I have a couple of scripts loaded here. So one is for creating sample Oracle database, and then I have some C#, and then for Access database, MySQL database, C#, combo box example. So basically, I'm going to just use that one, first one. And then if this one has a lot of code, so we are going to move down a little bit, move down. Okay, follow me, and then you'll be able to see a couple of places. First one is create a help desk database. Okay, create a help desk database. So I'm going to select from that. This dash means comment. It's comment. So basically remark. Okay, just say this is not a comment. It's not actually executable command. So just comment. Okay, and copy that all the way to here. So say publisher database. Okay, before that, So copy everything, and then log on to SQL developer. SQL.
Can you go to start copying from again?
So start copy from help desk database right here. Okay, and all the way to the beginning of creating publish your database. Okay, and then go to data SQL developer, log on as a user. Okay, so I think we are going to log on to eCourse again, even though some of you are on campus, but most of you are not. So I will log in. Okay. Okay, perfect. And then here I'm going to just say paste. So just go to edit, paste. Okay, so I have many comments. Okay, so to run this, I'm going to select all of them. Don't select partial sentence, partial comments. Select compare comments completely, and then press run button, run statements. So then that will create all the buttons. So until you see that table request, table is created, rows inserted, that means you're right. And then if you see some other things, the table view does not exist, that's fine because you do not have those tables yet. Okay, so if you run them again, then you should have no errors this time. Get that? Okay. Finish that, and I'm going to ask you to create more of the sample tables. Okay. Are you done with that? Anybody has questions, problems? Okay. And then second, I'm going to ask you to create a second one, which is HR database. Create HR database right here. And then all the way to before creating user tables. So select those ones, and then copy, and then go back to SQL or developer, and then paste them. And now let's create a second set of tables. Okay, so let's select all of them and run all of them. Okay, so you should have a table created and all rows are inserted. Okay, so if you say those table view does not exist, those are standard, those are fine because you don't have those tables yet. But if you run them again, you should have no errors this second time. Okay, let me see whether anybody has questions.
Where did that last one end when you highlighted it?
Just before creating gas logon database. Got it? Okay. So now after you run, so in the future, you probably when you do data manipulations, you may delete things or change things. You want to get it back to the same thing again, then just go back to here and then copy the same statements and rerun it. Okay. Now let me double check to make sure you have all the tables we need for next class. Okay. So I'm going to delete that. So first of all, you know how to select or say all the name of the tables you have, right? So you go to say table name, run user underscore tables, right? So that will show you all the tables you have. Okay, so the tables you just created should be in there. So for example, requests, responses, and then DEPD, let me check those two tables. So let's say describe, DEPT. You should have that table created. And that table, yeah, I show you here. We have a table with a couple of columns in that. Let me see. It has table name, department name, and let me see. Let me move this up. Okay. Okay, so here it has three columns: department name, department number, department name, department number, department location. Okay, let's do it again. Let's say describe EMP. Let's say we have that table. Read it. And again, that table has a bunch of columns, the employee number, name of that, okay? Can you tell the relationship between employee number and the manager here, MGR? So let me give you that data in the tables. So select, let's say select everything from DEPT. So we're getting to the department table. We have only 4 rows. Okay. Let's do it again, select everything from MP table. Let's say that table has more rows. Okay, so that is slightly larger table. So with employee number, so here you probably can tell the relationship between manager column and employee column, employee number column, right? So basically the manager is like a foreign key, right? You see the foreign key here, 7839, 7839. The employee number. So basically it tells who is the employee, who is the manager of that particular employee, right? Okay, so if you have all this if you have these 2 tables and also response request tables, we will need it later. Then you will be ready to move on to data manipulation languages for Monday. Okay. Now take a look at your homework to see whether you have any questions before we quit today's class. Take a look at your homework. We have like 5 minutes, I believe, right? So let me take a look at that also. So if I go to weekly outlines, I think it's a week 7 outline. And then you see that you're going to have multiple choice questions and also have 2 questions on normal forms. The first one, do you see similarities of this example to the one we did last class? So you have to start fixing from the first normal form and then move on to the second normal form, third normal form, step by step, okay? So then there's the last one. The second question is basically just ask you to identify whether there's any Boyce-Codd normal form violations. All right? Does anybody have questions? Okay. Now, if there's no questions, yeah, you have a question? Multi-valued attributes, yeah. So basically, you look at here, each ID, what is this? Is that custom ID or custom ID account number, right? So there's maybe like a custom ID, and then along with each one, you have many different transactions, right? So for example, transaction, debit, the transaction amount. So this transaction number, transaction type, and the transaction amount are all multi-valued attributes, right? You see the cell has multi-values because corresponding to each account, each customer, there's multiple transactions, right? Do you see that?
Yeah.
Weak entity for transactions, yeah, yeah. Because all these weak entities, all these repeating attributes kind of like go together, right? Yeah. Yeah. Right. You basically create one weak entity for all 3 columns. Yep. All right. No more questions. Anybody from online have questions?
Can you show me how you put the 2 tables on the developer really quick? My computer froze up.
The computer froze up? Okay.
Yeah.
So go back to...
And you put the 2 tables in the same page too, right?
Yeah. So if you go to, so you find a place, right? So the script loader, and see right here.
Okay.
So you
Yeah.
go all the way down to find. So first one, help desk. So I'm going to show you that. Okay, so select help desk
Okay.
all the way until you see publish your database. Before that, just select copy, select everything and copy.
Okay.
Now you go to SQL developer. Here, so paste all the commands in there.
And then you run it, right? Yeah.
Select all of them and run.
Mm-hmm.
Select from the beginning and run, like press this run button. And then,
Yeah.
okay? And then do it again for EMP table and the DPT table. So which will be the second one, HR database. Right. So select create HR database starting from here, from the screen map, and then before creating user guest login database. Just a second. And then select everything. Go to SQL developer again and paste. Okay, so now select everything and run it again. Okay,
Okay.
do you get it?
Yeah. And then the
Yeah.
select table, where did you put that?
Say it again.
The last part, the select table name from the user tables.
Oh, okay. So just say you want to see all the tables you have. So select table underscore name from user underscore tables. Okay, so that basically will show all the names of tables you have. And then you say describe DEPT. That will show whether you have DEPT table with the columns. And then describe EMP. And then say what the columns for the EMP table. All right, and now we can also say the data inside those tables. So select start from EMP, semicolon, and then you would see all the data in the column in the table.
Okay.
Okay.
All right. And you didn't put that at the bottom of the two of them, right? You put it on a separate.
You can put it in the bottom. You can just do. I was trying to save my screen space, so you can type all the commands sequentially. So all you can type multiple commands, and then you can just save everything when you finish it. So
Okay.
so when you run all the commands together, then just select all of them. If you just run one command, just put a mouse inside the command and then run that.
Okay. So I can just put this at the bottom of the two tables.
Yeah, you can do that. Yeah.
Okay. All right. Thank you.
Yeah, no problem. All right. Anybody else has questions? So let me start the recording for now.
Yeah, I have a quick question.
Sure.